Okay, so we're back. Arithmetic sequences and functions. As you could see from example 3, the graph of the first 5 terms of the arithmetic sequence lie on a line. An arithmetic sequence is a linear function in which n is the independent variable, so it's like the x, and an is the dependent variable, which is like y, and d is actually the slope, which is like m. So the formula can be rewritten as f of n equals n minus 1 times d plus a1, where n is a counting number. While the domain of most linear functions are all real numbers, in example 3, the domain of the function is the set of counting numbers, and the range of the function is the set of integers on the line. This is what I was talking about. You're not connecting the points on the line because they are just individual points. Now, Marisol is mailing invitations for her quinceañera, I can't pronounce that word. The arithmetic sequence, 42 cents, 84 cents, $1.26, $1.68, represents the cost of postage. Write a function to represent this sequence. The first term is 42, and then the common difference is 42 cents for each one of them. So since the common difference is 42, the first term is 0.42. We can substitute those in, distribute, and simplify, and see that the function is f of n equals 0.42n, 0.42n. So if I want to graph the function and determine the domain, the rate of change of the function is 0.42, so we can make a table and plot some points. We already know the first 4 from the given information. We can get a 5th one by just doing the 5th term, which is 210. So now I can plot those points, and they form a line. Again, we're not connecting the points because there aren't values in between 42 cents and 84 cents in the context of this situation. Basically, in this situation, the stamps cost 42 cents each. That's what the slope of the line represents. So you wouldn't really have, 43 cents, 44 cents, and things like that. All right, so the domain of the function is the number of invitation she mails. So the domain is 1, 2, 3, 4. And yeah, determine the domain. Notice we put it in braces so that it's a set notation. All right, the chart below shows the length of Martin's long jumps. Write a function to represent this arithmetic sequence, then graph the function. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So I know that A1 equals 8, and if you look, each time it goes up by 1.5. So that's D is 1.5. So AN equals A1 plus N minus 1 times D, so which is 8 plus N minus 1 times 1.5, which is going to be 8 plus 1.5 n minus 1.5. So it's going to be 1.5 n plus 6.5. Okay, so I already know this table basically here is my x and y, and I could figure out a 5th one just by adding 1.5 to it, which would give me 14. So 1 goes with 8, 2 goes with 9.5, 3 goes with 11, 4 goes with 12.5, and 5 goes with 14. Okay, looks pretty good. All right, and the domain is 1, 2, 3, 4, 5. And notice I'm going to put the ellipsis on there to indicate that it continues in that same pattern. Alrighty? All right, guys. Hope that video helped you out. Please continue on to your assignment. Reach out to me if you have any questions. And as always, make it a great day. Take care.